Good morning, everyone. Today, I will present about study of the effectiveness of a smart drainage system for reducing flood risk in residential areas. My name is Hazina binti Mafiz and my partner is CS Engku Shahul Rizal Engku Abdul Rahman. Many major drainage systems become clogged because of poorly managed drainage systems. Taman Sri Muda Klang Selangor experienced a major flood disaster in 2021 when it rains continuously, leading to damage to residents' homes, properties, and vehicles, as well as involving residents' lives. As a result, a study of the drainage system in the residential area was conducted, followed by the implementation of a system design proposal to address the flood problem. The main objective of this study is to conduct an initial investigation through the effectiveness of the drainage system at the study location. Then, research carried out to design a new drainage system that may transport water effectively, and finally, analyze the data from the result of the study. This diversion drain system can drain and divert water drainage to additional drainage while also shortening the water path to the main drainage. The drainage system, according to Musa 2021, works to drain surface runoff from building areas, paved areas, road areas, and other impermeable areas to safe areas such as river and lake. A good drainage system must be able to handle runoff water and dispose of excess water via gravity drainage in order to prevent the formation of water on the roads and ground surface. Road drains or ditches, stormwater pipe culverts, and other structures designed to carry surface runoff are examples of this system. Failure to maintain the drainage system contributes to the occurrence of floods, particularly in residential areas, by Hassan 2022. This issue is also caused by the construction of an unsystematic drainage system that is not built to the specified size. A drainage system that is not properly constructed will not be able to handle large amounts of water. Ismail 2020 explained that the flood can occur when river water overflow from its banks, and this overflow occurs as a result of non-stop heavy rain for several days in a specific location. Clogged drains may generate new issues, especially if heavy rains fall and cause flash floods. Methodology. This study examined the effectiveness of smart drainage system in housing estates at risk of experiencing flash flood and floods during monsoon season. To prevent clogging issues brought on by debris carried out by the water flow, this system utilized the diversion drain system technique and is equipped with a special garbage trap at the connection section of the inlet diversion channel. The flowchart in Figure 1 forms a framework for the methodology of this study. The sketch for this diversion drain system (DDS) is based on Figure 2 and inspired by the smart tunnel diversion structure which is used to divert and drain water's drainage to lakes, rivers, or the sea. To improve the drainage system efficiency, changes were made to the design structure, measurements, and additions. The garbage trap at the diversion channel inlet is described in detail in Figure 3. Its function to keep garbage out of the channel. Garbage traps are used to stop debris like plastic bottles, drink cans, dry leaf, and others from entering the drainage system so that the DDS can continue to work efficiently even when there is a lot of debris. According to Figure 4, this DTS works by diverting and draining the water through the diversion channel, and then the water flow downstream to the river, temporary water reservoir, or lake. The system can function when the water level of the main drainage system in the upstream reaches until it reaches the suitable level for the DDS to function. Situations like this frequently occur when heavy rain occurs, dumping garbage into drainage system, causing the drainage system to become clogged. As a result, by improving the drainage system, the rising water level can be reduced from until it overflows from the drainage system, causing flooding. Following that, it is recommended to install a garbage trap on the top of the drainage system as a drainage system cover to prevent trash from being dumped into the drainage system. Smart Drainage System DDS is composed of three separate systems. First, Diversion Drainage System DDS, which is located in the study area. It functions by diverting and draining water through the diversion channel, after which the water will flow downstream and reach the second system. The second system, the temporary reservoir, which will be filled with the water from the DDS. A water level sensor can generate a notification like and a sound whenever the water level in this temporary reservoir reaches the maximum level. The storage water tank is the final component of the DDS, SDS, and it will store water from the temporary reservoir while also releasing it into lakes, river, or water treatment ponds. In addition, water from the storage water tank will be used for common things like fire hydrants and greenery plants for the IBS green system. This Blender software is used to create a 2D or 3D version of the proposed DDS prototype design. This software contributes to achieving the realization of the proposed prototype design. This software additionally may be used for video editing, rendering, 3D and 2D model design, sculpting, VFX, and simulation. Figure 6 and Figure 7 show the DDS 3D design and also the temporary reservoir, pool, and water storage tank. Qualitative method. This study was conducted using the qualitative method of observation and interview, which is the qualitative method of the respondent belief, understanding, opinion, and view. The chosen study area, which is the existing drainage system, is observed using the observation method. This method can identify conditions in the drainage system and the environment, such as the dumping of waste into the drainage system, the frequency of rain, and the increase in water level in the drainage system when it rains. Result and discussion. Qualitative study analysis. The questionnaire distributed to respondents via the online form, which was complete and answered by 308 respondents. As shown in Figure 8, the feedback relates to the satisfaction with the SDS reservoir warning sensor. It is suggested that this warning sensor may be utilized as an emergency indicator for residents to move to a safer location immediately. 63% of respondents strongly agree and 29% agree. Following the reaction received is 60%, 68% strongly agree and 24% agree that this SDS be introduced in area at risk of flooding as shown in Figure 9. DDS effectiveness. DDS is designed with the existing drainage system to the underground drainage pipe connection so that flood water in the housing estate area can be drained out more efficiently and quickly than the standard drainage system. The water will subsequently continue to flow into the reservoir, which will be equipped with warning lights to better prepare residents if the situation worsens and flood occurs. Residents will be aware that the temporary reservoir has reached a drainage level and will be prepared to save themselves, their family, and valuable items. This is this DDS is equipped with the garbage trap to reduce the problem of clogged drains, and it will be monitored by the authorities and rain system management. For the conclusion, based on preliminary studies and software simulation, DDS has been shown to be more effective than existing drainage systems. With the existence of this DDS, residents will be able to be more alert in addition to decreasing the problem of flooding by providing residents more time to act if flooding is expected due to the warning system that has been designed. Based on the feedback received, the new drainage design prototype, the SSP, has received a positive response, which may contribute to settling the study objective. Based on the feedback received, the new drainage design prototype, the, the SSP, has received a positive response, which may contribute to settling the study objective. Thank you. That's all from me.